Our next area of study in geometry is going to be a look at right triangles and a little bit at trigonometry. We're going to begin this with the Pythagorean Theorem and its converse. Now, most people by the time they reach geometry have already worked a little with the Pythagorean Theorem. We're going to do some more in-depth look during this study. For starters, the Pythagorean Theorem reads, the sum of the squares of the two legs of a right triangle is equal to the square of the hypotenuse. Now, in a picture sense, if I have a right triangle, and we were to call it triangle A, B, C, we normally name the sides with lowercase letters opposite their vertex, so we'd have A, B, and C. The Pythagorean theorem says that a squared plus b squared, the sum of the squares of the two legs, is equal to the square of the hypotenuse. And when we have this relationship, or at least any two parts of a right triangle, we are able to find the third. There are ways of generating Pythagorean triples and looking for different relationships that exist therein. But let's take a look, see if we can find a couple on our own. If, for instance, we are told that the two legs of a right triangle are 10 and 24, how would we be able to find the hypotenuse? Well, if these are the legs, we say 10 squared plus 24 squared, and it really does not matter which one is A or B, will equal the hypotenuse squared. So 10 squared is 100, 24 squared is 576, and that will equal the hypotenuse squared. Next, I add these together and I come up with 676 is equal to c squared. Then to find c, I take the square root of both sides and I end up with 26 being c. Next, what if we were given a hypotenuse and one of the legs? So let's say C is 12 and one of the legs is 6. And we want to be able to simplify this down into radical form. So we begin with our formula, and it does not matter, like I said, whether this leg is A or B. So just to make it easy, I'll say a squared plus 6 squared equals 12 squared. Squaring this, I have a squared plus 36 is 144. Using subtraction property of equality, I know that a squared will be equal to 108. So a equals the square root of 108. Now, wanting to simplify this a little bit more, I know that 108 is 36 times 3. And using properties of radicals, or square roots, I can take the square root of one part and leave the other. So the square root of 36 is 6, and square root of 3 I will leave behind. So when we're given some information, we're able to go through and find the other parts of a right triangle thanks to the Pythagorean theorem. Now, when we have this theorem, along with it comes its converse. So let's take a look at the converse here real quick. Theorem 8.2, which is going to be the converse of the Pythagorean theorem, reads, if the sum of the squares of two sides of a triangle is equal to the square of the third side, then the sides form a right triangle. So let's take a look at a set of sides and determine if they would make a right triangle. What if we were given side lengths of 16, 48, and 50? Do these form a right triangle? Well, if this is going to be a right triangle, by our hinge theorem, the largest side, 50, would have to be the hypotenuse. So we need to say 16 squared plus 48 squared, and we want to know, is that equal to 50 squared? Well, going through and doing a little bit of arithmetic, 16 squared is 256, 48 squared is 2,304. And we want to know, is that equal to 50 squared, which is 2,500. Now adding these pieces together, we have 2,560, and that is not equal to 2,500, so no, these sides will not form a right triangle. Let's take a look at a different set and test to see if those would work. Let's try 11, 60, and 61. Again, our longest side would have to be the hypotenuse, so we're going to try 11 squared plus 60 squared, and we want to know, is that equal to 61 squared? 11 squared is 121, 60 squared is 3,600, and we want to know, is that equal to 3,721, which is 61 squared. Well, adding our left side together, we get 3721, and that is equal to 3721. So yes, these three sides will form a right triangle. So if the pieces of the sides do satisfy the Pythagorean theorem, then we know that we have a right triangle. But what about situations like this 164850 where it does not satisfy it? What then? Well, there are two theorems that go along with this. Let's take a look at them real quick. Theorem 8.3 states, if a squared plus b squared is less than c squared, then the sides will form an obtuse triangle. And along with that, Theorem 8.4 tells us, if a squared plus b squared is greater than c squared, then the sides will form an acute triangle. So let's take a look at a couple sets and see what we come up with. What if the sides we have are 7, 8, and 9? What type of triangle will this make? Well, let's calculate these on their own. So we have 7 squared plus 8 squared. We want to know how that compares to 9 squared. 7 squared is 49, 8 squared is 64, 9 squared is 81. Adding this together, 49 plus 64 is 113, which compared to 81 is greater. So since our a squared plus b squared is greater, these will make an acute triangle. Now let's take a look at a set like 1, 2, 3, our first set of natural numbers. What type of triangle would these make? Well, we have 1 squared plus 2 squared, and we're comparing that to 3 squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, 1 plus 4 is 5, 9 is greater than that, so these would make an obtuse triangle. So our relations that exist with the Pythagorean theorem do come out to help us find right triangles, but they can also tell us if we're finding a triangle that is either acute or obtuse just by looking at the inequalities. Now this is going to be a basis for moving forward into other parts of right triangles, especially our study of trigonometry in this unit. So make sure you have these ideas down and are ready to use them.